Hello, this is the generally approachable Sudoku for the 15th of March 2024. It is Martiae, I think that's how you pronounce it, by Philip Newman, and it is an anti-king clone Sudoku, so two different variants today. So, the rules are, place the digits 1 to 9 every row, column and 3x3 box, those are classic Sudoku rules. Anti-king, so digits separated by king's move in chess cannot contain the same digits. So for example, take this 4 over here. This 4, if it were a chess king, could move into 8 of those 8 cells there, right? So none of those cells can have a 4 in it. So even though by regular Sudoku, those cells could have 4 in them, they cannot by anti-king rules. Okay, the other rule is clone. So regions of the same shape and letter are clones. So all 4 of these with A in the corner, those are clones. So they must contain the same digits in the same relative positions. So if this was a 3, for example, if this was a, let's say an 8. Let's say this was an 8, for example. Then this digit would have to be an 8 as well. And so with this digit, and so with this digit. And yeah, those are all the rules. With that, let's just begin solving. Alright, so let's start with the 9s. Yeah, the 9s by regular Sudoku just get placed into here. I suppose all the numbers here also do get very interesting stuff. This 1, for example, can't be in any of those cells by king's move. This 1 eliminates all of those cells and that cell by king's move, so 1 can only be here. By the exact same logic, 2s can't be in those cells, so 2 must be here. 3 must be here. 4 must be here. So yeah, very interesting logic already. Now, let's identify, probably to do with clones maybe. Clones? So, yeah, okay, so for example, let's take a look at this. 6. No, this is not a very good idea to think about. 4s. 4s actually see all of those cells, right? And it might not seem very useful at first, but notice that those cells are equal to those cells. And let me just color those blue to show you. So this 4 sees those cells which are the same as those cells because they are clones. And therefore, in fact, 4 cannot be in any of those cells. Which means 4 is not in the clone. And interestingly, I'm pretty sure we can do the exact same thing with every other number from 1 to 4. So 1, because it can't be in those cells, cannot be in the clone. 2, because they're in those cells, cannot be in the clone. 3, because they're in those cells, because they cannot be in those cells, they cannot be in the clone. And 4 cannot be in those cells, so they cannot be in the clone. So those are 4 digits that are not allowed to be in the clone. 9 over here, because 9 can't be there, this 9 can't be there, this 9 can't be there, this 9 can't be there. That covers all 4 possible spots in the clone. 9s also cannot be in the clone. And so that means if 1, 2, 3, and 4 and 9 cannot be in the clone, the only remaining possible digits are 5, 6, 7, and 8. And we can also prove that all 4 digits in the clone must be different, and by king's move that is possible, because whatever this digit is must be different from all 3 of those. Correct? Same for that digit, whatever digit that is must be different from the 3 of those, because it is different from those by regular Sudoku and that by king's move. Same for that cell, and therefore because all cells are different from each other, they are 4 distinct digits. And because they are not 1, 2, 3, 4, and 9, they're actually 5, 6, 7, and 8. So that is wonderful logic. Wow, that is actually so clean. Okay, so let's start doing stuff. 5 can't be there, so they can't be in those cells either. Notice though that those are the exact same cells relative to each other. Those are in the exact same relative positions. So we can't transfer that to other parts of the cage. 6 can't be in those cells, therefore can't be there. 7 can't be in those cells, therefore can't be there. And 8 can't be in those cells, therefore can't be there. So that gives us a very nice looking 4 of a kind chocolate teapot. Chocolate teapot. Okay, so now what? Well, I suppose we might want to work on other numbers in the meantime. Like 2s, for example. See all those cells, so 2 must go there to the digit. 1s are not in those cells, so 1 must go there. Same for here, I guess. 3s? Yeah, 3s have to go there. 4s by symmetry have to go there. 1s here come in those cells, so 1 must go there. 2s come in those cells, so 2 must go there. 3 must go here. 4 must go here. So all very rotationally symmetrical so far. I suppose this is a pair of 8s, right? Which means none of those cells can be 8. That's fair. Actually, every other cell in these 5 squares are all just the digits 5, 6, 7, 8. That makes sense though. Alright, let's do other stuff. What else can we do? 2s? I mean, 2s maybe. Not really though. Yeah, 2s don't really seem to do much anymore. Yeah, 2s don't do much. I guess, where does 2 go in this column is the correct question. 2 cannot be there, so 2... Well, 2 can't be there by King's move as well. Yeah, I didn't see that. So 2 must be here. Which means in this box, 2 is now forced into one of those cells, I think? Yeah. Okay, not very helpful. Never mind. Alright, let's look for the others though. Like for example, 1 in this row can't be there or there by those ones, so 1 must be here. For this column it's the 4s, which must therefore be over here. And for this column would be the 3s, which therefore must be over here. I could probably do other stuff with this now that I have more information. No, I don't think so. I think it's still very awkward. No, yeah, I don't think I see anything useful. Like all the 4s do is 4s do that. And then here it's over here, and then here it forms some random... Wait, no, it's like this. Those are where 4s can be. Which means that this forms a very weird looking pair, but you can never resolve those. And by symmetry it will be the same for 1, 2s, and 3s, so you wouldn't be able to resolve those either. So I think it's something else then. It's like, it is probably something else, like... But what though? I want to say, I don't want to use meta logic too much, but I want to say... Oh, we can work with the 9s. I wanted to say that any deduction we make on all of the digits can be made in the other 4 corners, in the other 3 corners, because it's rotationally symmetrical. But, you know, I can't prove that, so I don't think I should. Anyway, those 9s looking at this box, in fact tell us that 9s can't be in those cells, therefore 9 is one of those cells. This now focuses here and tells us that this must be a 9, because 9 can't be in those cells, and wherever 9 is here would see that, and therefore 9 has to be here. And all we say is just in this row, where does 9 go? It can't go there, so it must go there. And we can actually repeat that. 9 can't go here, so it must go here. By similar logic, it must go here, and because of this, it must go here. Right, so that gives us, well, those are all quadruples, correct? Yeah, so the last digit in here we haven't marked out is a 1. For here it's a 4. For here it's a 3. For this it's a 2. Which should give us more stuff to work with then. Yeah, like 1 now can't be there, so 1 has to be here, which pushes a 1 into here for this box. Which pushes a 1 to... Well, that's all the 1, sorry. Yeah. As for this, a 3 now can't be here, so 3 goes here, which forces 3 over to here. I think that's all the 3s? Yes, okay. 2s are probably somewhere else. 2 here now must be here, which pushes a 2 in this box into here. Yeah, now this 2 makes... This is not a 2, so that has to be a 2. Alright, fair enough. And the last digit will be a 4, which we haven't worked out yet. 4 has to be here in this box, which means it has to be here in this box. That is all the 4s. Okay, so now the digits 5, 6, 7, and 8. To resolve them all. How? In the corners here we all have the triple. So this is 5, 6, and 8. This would be 5, 6, 7. This would be 6, 7, 8. And that would be 5, 7, 8. Oh, this 5 means that it's no longer 5. So the only place 5 can go in this box is down here. And that should begin everything. Because of this clone, we can put that exact same section everywhere else in here. Nice. Alright, very satisfying. This should solve the rest of our problems. That's now a 6. This is no longer an 8, so it's a 7. This would be an 8. This would be a 5. Those digits are 6 and 7. This 7 resolves that. Those digits are 5 and 8. This 5 resolves that. Those digits are 7 and 8. 8 resolves that. Those digits are 5 and 6, 6 resolves that. Whoa. And the last 4 digits will be 5, 6, 7, and 8. We can place a 7 pretty easily. 8 will follow. 6 goes here, and the last digit 5 solves the puzzle in 8 minutes and 58 seconds. Well, this was very satisfying, very symmetrical. Still have no idea what Idus Martiae would mean. Idus? Idus Martiae? Sounds like some... I don't know, but okay. Well, I think that was cool. Hope you enjoyed this video. I'll see you guys next time. Bye bye.